Hello and greetings everyone. Today we want to present our group case study on topic disaster or accident that happened and how principles of green chemistry can be used to prevent the disaster or accident. First, let us introduce ourselves. My name is Nurul Sharzabunti and my matrix number is 33DFO20F2008 and my partner is Susanna Manandi and her matrix number is 33DFO20F2006. Our topic today is 1924 NIXON nitration disaster. The 1924 NIXON nitration works disaster was an explosion and fire that claimed many lives and destroyed several square miles of New Jersey factories. It began on March 1, 1924, about 11:15 a.m., when an explosion destroyed a building in Nixon, New Jersey and area within present-day Edison, New Jersey, used for processing ammonium nitrate. The explosion touched off fires in surrounding buildings in the NIXON nitration works that contained other highly flammable materials. The disaster killed 20 people, destroyed 40 buildings, and demolished the tiny industrial town of Nixon, New Jersey. Prosecutor John E. Tulin of Middlesex County, New Jersey, began an inquiry 2 days after the blast. Among those summoned to appear for the inquiry were Lewis Nixon, his son, Stanhope Nixon, and Arnold Shreve, then president of the Ammonite Company. Secretary of War John W. Week also ordered an inquiry for the more limited purpose of determining whether the Raritan Arsenal was in any way responsible for the explosion. Some theorized that the blast was triggered by small quantities of TNT that remained in the ammonium nitrate at the Ammonite facility after the ammonium nitrate was removed from the shells. Lewis Nixon embraced this explanation. Ammonite disputed this theory, asserting that the average content of TNT in the salvaged ammonium nitrate was only 0.2%. However, under questioning, Shreve acknowledged that this would have caused 120 pounds 54 kg of TNT filtered from ammonium nitrate to flow every day into a small stream on the site, and that there might have been several percent of TNT in tanks of ammonium nitrate remaining at the site. Major A.S. Cassand, commander of the arsenal, also disagreed that residual TNT was to blame, and believed that the explosion was due to conditions in the plant. 2 days after the explosion, newspapers reported that 18 people were killed, 2 were missing, and presumed killed, and 15 others remained hospitalized. The blast injured 100 people. The dead included the wife and 3 children of an employee of the plant who lived 100 yards from the scene, a stenographer working at the plant, and 13 workmen who were repairing the roof of the building where the blast occurred. Let us look, for instance, at the recent chemical accident in Nixon, New Jersey. The disaster began when ammonium nitrate in the Ammonite building exploded. Windows for a mile around the scene were broken inward and doors were blown from their hinges. The blast shook Staten Island, where business buildings in the Stapleton and St. George neighborhoods rocked, windows rattled, and doors were slammed. It was felt in lower New York City, Brooklyn, and as far away as Mineola, New York, 50 miles away. The flaming debris from the explosion soon set cellulose nitrate sheets afire in nearby buildings. Fires began to consume other buildings as well, including the offices of the nitration works. 6 hours after the explosion, flames were still burning over an area of 1 square mile. As darkness fell, shifting lines suddenly began fanning the flames toward freight cars on a siding and toward the nearby Raritan Arsenal where 500,000 high-explosive shells were stored. 4 of the arsenal's high-explosive magazines had been crushed by the initial explosion and the roofs of 2 others blown in. Through the efforts of exhausted firefighters, the fire did not reach the arsenal. The facility is also required to have a risk management plan. The product the company makes is designed to contain only small amounts of hazardous components, which are dissipated in use. All these measures make sure any contact of the dangerous chemical with the environment or humans occurs in a small-scale, controlled manner. The facility is also required to have a risk management plan. The product the company makes is designed to contain only small amounts of hazardous components, which are dissipated in use. All these measures make sure any contact of the dangerous chemical with the environment or humans occurs in a small-scale, controlled manner. This, however, does not eliminate risk itself. It is strictly controlled, but it is still there. When accidental fire caused several explosions at the facility, the tanks containing the hazardous chemicals, mostly ammonium, were ruptured, and the hazard was forced out of containment. Chemicals were apparently released to the nearby area and possibly leaked into the nearby lake via stormwater stream. The immediate response included the measures such as evacuation of public from the area, ban for using lake for fishing or other activities, isolation of the spill, and clean up the affected soil and surfaces. Possibly, also the risk management plan will need revision to make sure that such harm is avoided in the future. In the current situation, all these measures are appropriate, but they are all again exposure limiting. And, therefore, they are limited in effectiveness. Green chemistry approach calls for minimizing the hazard. Instead of controlling methanol, get rid of it. Use a non-hazardous material instead. If it leaks, there is no hazard. No hazard, no risk. However, this approach clearly requires some expertise and investment from the company. Because the company, even though wanting to be green, wants to stay competitive and profitable, green approach is a technical challenge for product designers. Occupational Safety and Health Administration, OSHA, regulates workplace safety. OSHA's regulations for air quality often come in the form of permissible exposure limits, PELs, for workers. These standards limit how much of a certain substance a worker can be exposed to over a typical shift. If exposure exceeds that limit, an employer can be cited and possibly fined. OSHA maintains 10 regional field offices, as well as area offices in most states, to inspect facilities, help employers meet the regulations, and enforce the rules in case of non-compliance. The Environmental Protection Agency, EPA, sets rules to limit environmental pollution. A manufacturer that produces contaminated air in any serious volume should be aware of both sets of regulations. The EPA's regulations are different. Most of the relevant standards for manufacturers are based on the Clean Air Act. These regulations limit how much of a particular substance a company can release into the environment. Their concern is the health effects of these substances on the surrounding community. The EPA maintains a list of air emissions sources: nitrogen dioxide, NO2, ozone, O3, sulfur dioxide, SO2, particulate matter, PM, carbon monoxide, company, lead, PB. Some of these limits affect typical manufacturers. If a facility is producing contaminated air, say, through a large welding operation and exhausting all of it to the outside, the company may be breaking EPA regulations. Failure to comply could lead to citations and penalties.
Throw your hands up if you with it, drop it.